Assalamu alaikum wa rahmatullahi wa barakatuh. And welcome back, my dear students. After practicing on paper 2, today, inshallah, we are going to move into the main challenge, paper 4 for chapter 1. Let's start. Bismillah. I picked some questions, one question from year 17, another from year 18, a third one from year 19. Inshallah, we are going to finish with them today. Let's start by saying Bismillah. With the first question we have here, figure 2.1 shows a measuring cylinder that contains a colored liquid. Okay, the measuring cylinder contains 82 centimeter cube of water, so the volume equal 82 centimeter cube. And the density of the liquid is 950 kilogram per cubic meter. So the density is 950 kilogram per cubic meters. Calculate the mass. Density equal mass over volume, rearranging the equation, making the mass the subject, mass equal density times volume. So the mass must be in kilograms. So we need to convert the volume from centimeter cube to match with meter cube. So in order to convert it from centimeter cube into meter cube, we are going to multiply it by 10 to the power of negative 6. So 82 times 10 to the power of negative 6 multiplied by 950 will give us the mass in kilogram. So it's 82 times 10 to the power of negative 6 multiplied by 950 is equal to 78 times 10 to the power of negative 3. 78 times 10 to the power of negative 3 kilogram. That's for the first part of the questions. Okay, Shabab? Let's go to the second part. The height h of the liquid in the measuring cylinder is 0.094 meter. So here is h, the height, 0.094 meters. Calculate the pressure due to the liquid at point X. Is asking for the pressure. You know, pressure of a point inside the liquid, here is the height that is given to us, 0.094 meters. You know, pressure of a point inside the liquid equals to rho GH. G is 9.8 or 10. For simplest, I'm going to consider it 10. But in the updated syllabus, it becomes 9.8. If the examiner didn't force us to write it 10, you can write it, you should write it 9.8. Actually, I'm going to use 9.8. It is more accurate, 9.8 meter per second squared. So what is the density? The density is given to us 950. What is G is 9.8. What is the tips is 0.094. So let's find the result. 950 times 9.8 times 0.094 equals to 875 Pascal. I'm going to write it within two significant figures because the number here is within two, the number here is two significant figures. All the number actually in the given data within two significant figures. So I cannot write it within three significant figures as the calculator gave it to me. So I'm going to write 880 Pascal. So here is the pressure within two significant figure. The true pressure at the point X is different from the value calculated. If you look here to the value calculated, they are saying that the difference, one second. Bismillah. Okay. The true pressure at point X is different from the value calculated in P. Explain why. You know, it's an open cylinder, and of course, there is atmospheric pressure here, and the atmospheric pressure will exert more, and we should add it in order to find the total or absolute pressure at the point X. So I'm going to say due to the atmospheric pressure that should be added, as I said. Letter C, a small object is made of steel. It is placed level with the top surface of the liquid in the measuring cylinder and then released. The object sinks in the liquid. Explain why the object sinks in the liquid. Of course, there is a resultant force, and the density of the steel is bigger than density of the liquid, so it will sink in the liquid. You can write since density of steel is bigger than that of liquid. Describe how the volume of the liquid can now be calculated. I'm going to record the new volume, which is V2. Record the new volume after immersing the steel, V2, and I'm going to subtract it from V1. What was V1? V1 was 92, I think, 82. So V2 minus 82 will give us the volume of the steel. 82, and of course, it will be in centimeter cube. That's it. Let's go to question number 5. Question number 5. Question number 5. Here is question number 5. Question number 5 states that figure 2.1 shows a hollow metal cylinder containing air floating in the sea. Okay, we have all given data on the drawing. We have a hollow cylinder, and it is floating, made of steel, by the way, and or a metal cylinder floating in the surface of the sea. And here is the air above, and here is the height 1.8 and the immersed part of height of 1.2 meters. Everything is given, and the seawater and so on. The density of the metal used to make the cylinder is greater than the density of the seawater, so it's supposed to sink under the water. Explain why the cylinder floats, because it is not the density of the metal only. The density of the metal plus the air, the combined density of the metal and the air is less than the density of the seawater. The reason the cylinder floats, since the combined density of the metal and the air is less than that of sea water. The cylinder had a length of 1.8 meter. It floats with 1.2 meters submerged in the sea. The bottom of the cylinder had an area of cross-sectional section of 0.80 meter squared. The density of the seawater is 1020 kilogram per cubic meters. Calculate the force exerted on the bottom of the cylinder due to the depths of the seawater. Now we are going to go to pressure of a point inside the liquid. P equal rho GH. What is the depths here? We are going to go to density is 1020. G is 9.8. As we agreed, we are going to use 9.8. The depth here is 1.2. Okay. What is the result to find the pressure? Let's find it. 1020 times 9.8 times 1.2 equal 12 times 10 to the power of 3. You can 12 times 10 to the power of 3. 12 times 10 to the power of 3 pressure Pascal. he's not asking about the pressure, he's asking about the force. Pressure equals the normal force acting per unit area by cross multiplication. We can find the force. The force equal pressure times area. Pressure times area. The pressure is 12 times 10 to the power of 3 times the area, which is 0.80. We can find it like this. So times 0.80 equal 9.6 times 10 to the power of 3. 9.6 times 10 to the power of 3. What is the unit of Newton? The unit of force is Newton. The area is in meter square, and the pressure would in Pascal. So the force will be in Newton, obvious. So 9.6 times 10 to the power of 3 within two significant figures, which matching all the given data. Deduce the weight of the cylinder. Explain your answer. The weight is still the same, 9.6 times 10 to the power of 3, because it is the net weight explanation. Yes, is asking for the explanation. The net force equals 0, since the net force equals 0. So downward force equal upward force. So the weight of the cylinder will be equal to the up thrust force because it's floating. So it is equal to 9.6 times 10 to the power of 3 newtons. And that's it. Let's go to question number 10. Year 19. Question number 10. Question number 10. 8, 9. Question number 10. Question number 10, another idea. Figure 1.1 is the top view of a tank in an aquarium. The tank is filled with salt water. The depth of the water in the tank is 2.0 meter. Okay. Calculate the volume of the water in the tank. So we need to find the area of the surface. And then we are going to multiply it by the depth. It will give us the total volume. How we are going to find this? We are going to consider this a whole square like this. What is the missing part? This part is 1.1 meter, and here it will 1.1, but it will be 2.1 meters, and this one 3.2, 1.6, so 1.6 meter. We are going to find the total volume, the total area of the whole rectangle, and then we are going to subtract the small part. It will give us the area. So the area equal to 2.1 times 3.2 minus the total area of the large rectangle, and we are going to subtract this part. So minus, which is 1.6 times 1.1 will give us the area. So I'm going to open a bracket. 2.1 times 3.2 minus 1.6 times 1.1 is equal to 4.96. 4.96 meter squared. No need for any conversions. I'm going to make the final result for in the space provided with a two significant figure like all of them. So I'm going to multiply it by area times height will give us, or depth here, will give us the volume. So 4.96 times 2 will give us the volume. So times 2 equal 9.92 cubic meters, but I'm going to write it 9.9 cubic meters because I should write it within two significant figure, which is matching with the other values given in the problem. Here you can see that the density of the water in the tank is 1.1. So density equal 1.1 times 10 to the power of 3 kilogram per cubic meters. Calculate the mass of the water. We have the volume and is asking for the mass. You know, density equal mass over volume, rearranging the equation, making the mass the subject, mass equal density times volume. The density is 1.1 times 10 to the power of 3 times the volume, which is 9.92. You can use the exact value. It is better. And then I'm going to run. I don't want it. I don't think it will make any changes, but it is better to use the exact value. So I have it here in my calculator. I'm going to multiply it by 1.1 times 10 to the power of 3. It will give us 10.9 times 10 to the power of 3. I'm going to write it 11 times 10 to the power of 3. So it's 11 times 10 to the power of 3 kilogram. Calculate the pressure due to the motor at a bottom at a level of 0.8 meter above the base of the tank. So if the tank depth, as he said, 2 meter, 2.0 meter, and he said above 0.8, so I'm going to move up 0.8. So whatever left here is 1.2 meters. So H, or the depth, equal 1.2 meter. Calculate the pressure. Pressure equal rho GH. Again, rho, it is given to us because they said 1.1 times 10 to the power of 3. 1.1 times 10 to the power of 3 times G, which is 9.8, times the depth is 1.2. So what is the total here? So 1.1 times 10 to the power of 3 times 9.8 times 1.2 equals 12.9. I'm going to write it 13 times 10 to the power of 3. The pressure is in Pascal, so 13 times 10 to the power of 3 Pascal within two significant figures. And that's it for paper 4 today. So we bring the end, I think that brings us to the end of paper 4 question for chapter 1. Until I meet you, I wish you all the best. Assalamu alaikum wa rahmatullahi wa barakatuh.